Good evening, everybody, and welcome on into the Dragon's Den. My name's Digital Dragon. Hello, hello, hello. Hey, Tech Jeeper, Mr. Wizix, welcome on in. What are you all doing today? Coffee right here. Mrs. Dragon is out doing a Starbucks and Dunkin' Donuts run. Meanwhile, we're still doing our normal Black Rifle Coffee Company. Wild Dragon has appeared. That it has, Tech Jeeper, that it has. How's it going? We're in our photo cement moon dragon or moon knight dragon. This is the photo cement one. It looks kind of like the one that Creatix Brit painted for the Thangs contest. Got this going on today. Figured need why not rotate through, do some different shirts that I haven't worn in a little while, but still stay with the dragon theme. So got this shirt on today. In fact, just thought about it. Let me go ahead and grab one of our table mats and put it back up here. Move a couple of things around. Say table mat, it's more of a mouse pad, desk mat, all around. Cover and protect your surface so you don't bust it up. And of course, this is the hot end one. This is the Moon Dragon bust. Then this is the hot end one from 3D Print SOS. Hey, here's the Goliath, and here's a Goliath. So let's see how close it is to real deal. Our Goliath hot end. Lay it on there. Yeah, it's a little bit bigger. It's just a little bit bigger than real life. But that's okay. That's okay. So we've got the Goliath hot end. I did my research yesterday, actually Tuesday night and yesterday, figure out what we need to do with the Goliath. Thank you to Steve Builds and ModBot Army for streaming their build and providing a lot of good documentation. In fact, Steve Builds actually has a couple of files that I need to download and print a few of based on some of the changes that they had. And he's got some cool little quality of life changes that he does to several of the builds that he does. I'll be looking at doing that. We'll be mounting this today, as well as our Y end stop bracket. And I did print out an X and a Y end stop bracket, but we're going to use the nice CNC'd one that came with the kit. And speaking of our printer, here we go. So nice to have handles, and still not hugely heavy, but by the end of today, it's going to start getting there. Sorry. By the end of the day, we're going to have some of the front panel on. We're going to have a back panel on. We're going to have a bottom panel. Bottom panel, pretty thick aluminum. So we're going to start dressing up our printer some today. We're going to start by kind of going back and doing a couple of the things that we've missed on the build so far. Again, I'm going to turn the back towards you all. And depending on where we're at, let me push this back some and see. Yep, that'll get you an angle there. So if you remember, we didn't have the cable, the mounting fan and cable holder piece, which are window here. There we go. It's this printed piece right here that we didn't have. I figured it out. It was all me. I didn't print it, so I have that part printed now. We're going to go ahead and get that installed. I also printed the Endstop mount, so we'll get that installed as well. Now I did, I printed a piece. Well, we'll get into some of the other stuff that I printed here in a little bit, because there were some other things that that I printed out that we're going to have to make some adjustments or changes on a little bit as we go forward here. But we'll talk about that when we get. So this cable holder mounts with M3x6, so we'll grab a couple of those. Hey Tugboat, welcome in. Welcome in. We're not going to put any Loctite on these because we're going through a printed part. So we don't want to take the chance of deteriorating that printed part when we go ahead to mount this. And I don't think we're going to have an issue with my here. And we're just going to line up our flathead screw and get these screws. And there's a flat bottom and then a angled an angled side. The flat bottom goes down. Angled side kind of goes up in a flare. Installed. Then we got our carriage tray or carriage piece assembled, and on there our end stop bracket goes on this left side over here. And I'm not going to actually install the end stop just yet because, well, I'm gonna have to solder some leads to it because I don't think there's any pre-crimped cable here. So got this little part like this. The two small holes here will be used to mount the end stop to, and then the slots are what we're going to screw down onto our side here that will allow us to move it in and out. We don't necessarily have to do this. We could go with centerless homing on X and Y if we wanted to. I tend to, I've done centerless homing on some printers, but I think I just, second here to using the M3x6. I believe it's the M3x6 still when I do this. Hey Da Vinci, welcome on in. Hey, the Galactic Bee, thank you for the follow. Bexy sent you over to check you out. Awesome. And you're a 3D printing nerd? Even better. Even better. Us 3D printing people got to stick together. Now what I need to do is figure out which way this thing. Okay, so it looks like it kind of offsets to one side there. So the offset goes facing upwards. So we're just going to once again get these lined up, and I'm not gonna like ugga-dugga it down right now. I'm just going to get them started and just kind of hold it in place. Because once again, I will need to solder the wires to the end stop to get the end stop installed, and then it'll come up and go through our cable chain back. Sorry about the cough. He told you I had a massive collection. Well, uh, I've I've got a few printers here. So we've got our Bambu Labs X1 Carbon with a 4-piece or 4-spool AMS. There's a printer, whoops, down here that's really not working right now. This is the very first printer I have. It's a TiVo Tarantula. Sometime after Midwest Rip Rap Festival at the end of June, between that and East Coast, well, 3D Printopia, which is in Bel Air, Maryland at the end of September, we will be rebuilding this and reviving it. We have an Annex Engineering K3. This is a really nice printer. It's about the same size as this as far as the print area, print volume goes. Fully enclosed and everything. It's a really nice printer. Excuse me. We have our 0G Mercury 1. This is a prototype, we'll say, that was built to validate a full frame build for a 0G Mercury 1. This is still in closed beta. They're still making some modifications to it, but this is one that's out in the wild. I've taken this to several shows. We have a pair of Voron 2.4, 300 size, 300, can't remember the height on the 2.4s. And then in the corner, I've got my Trident, which is a 300 size. This is the one that has my Dragon logo on the side panels. We've got an Ender XY in the corner that needs a little bit of love. It's corner down under the Trident. We have a Prusa Mark IV. We just got a multi-material unit in for to build the MMU3. Over here in the corner, can't really see it too much, but right here is the black box build. We'll be working on that Saturday morning at 10 a.m. Eastern time. We're getting closer and closer to hopefully powering that up here. We're sorry, yeah, it's one of those things of 90% done, 90% to go. It's all the little fiddly things to get done. But the black box is a 5 spool head spool changer that is water cooled, uses Duet RepRap firmware for the electronics and firmware system. Very nice printer. That is a sponsored build by my sponsor KB3D. Speaking about KB3D, we've been talking about how we're going to be rebuilding the Rook 2020 into a Rook 2020 Mark II. What do you guys think about that? This will be the deck panel. I'm going to see about just trying to wipe it down with some alcohol to get some of that residual residue off. That is Vision Miner nanopolymer adhesive I use. This is printed in ABS multicolor on the Bambu behind us. That is the closest to the KB3D orange per Chris himself. So rather than taking and slapping a sticker on it, I went ahead and just printed it directly. So it's not 100% match on the color. And some of that could be that the black is bleeding through because I don't think the KB3D is very deep. So we might be getting, I'll say, some backlighting from the black behind it because it is all black on the back. But yeah, that's going to be the panel for my Rook 2020 Mark II upgrade. And then I've got one that I can't show off just yet because I still want it to be a surprise. It's going to be for Tugboat 3D folks. So you got to poodle off and help Maker with stuffs, but pop back later. Okay, Bexy, have a good one. It was great seeing your stream today. And so Bexy Beans does Disney Princess cosplays in the UK. and she was working on her bell dress over the last 2 days and completely redoing the, I think they call it the bodice part of it. And yeah, it's amazing how fast she was able to whip that out and how good it looks. Amazing work there. Oh, well, thank you, Galactic. And also, by the way, I have an Ender 5 Plus downstairs. It's been converted to a full 0G Mercury 1, which is the Core XY gantry system with a Hydra, which is a triple lead screw mod. And that's 370 by 370 by 420. Got an Ender belt conversion downstairs, a Prusa Mini, been slightly modified, a Trident 350 with a 8-part Enraged Rabbit carrot feeder MMU to it. The Bugaboo 210, the Rook 2020, a Fabrico Rook kit that's been built this downstairs. And I've got Flying Bear Reborn 2, 3 Prusa Mark III S bears. So they're using the aluminum bear frames, and a heavily modified Ender 3 that's over at the Dragon Den Site B, which is my buddy's house from the Air Force. He lives about 10 minutes. Cool. Yeah, I think that's going to look really good on that logo panel. I think it came off really well. So, okay, so we've got our sorry for yet another transition. So we installed the cable mount point. We installed the bracket for our end stop. We'll get back to that later on. Like I said, I will build the pigtail, and most likely what I'm going to do is, rather than doing a full home run cable that comes all the way down to the electronics backpack, I'm either going to have, find some type of breakout board that I like and do a breakout board, or something else to reduce the pain having to do maintenance on the spool head and take everything off and have the big long cable run. I really prefer to have all the connectors near the tool head, so you can take one like umbilical cable or a CAN bus cable out and take the whole tool head off and work on it without a lot of wires hanging. That is the only thing that really I hate about the Prusa like Mark II and Mark III. It's just every time you had to do something on that tool head, you had to take all the wires or almost all the wires out, and it was just a pain. This is being built from so the printer we're building today is a VzBot 235 by Vez, and this is a Mellow kit that I got off of AliExpress. They have a 235 and it's a 300 or 330 size. Hey Zombie, welcome on in. And so we're building this from the kit and following the build instructions. And right now we're just, I'll say, kind of tidying up a couple of things that that we skipped Tuesday because I didn't have some printed parts. We are going to change the fan duct. I have a tri-horn on here right now, but I did print another version. This is not a tri-horn, it's a side, but you'll notice this piece right in here. And this is made to mount a beacon probe underneath. And I do have a beacon Rev D. So we'll be using a beacon probe on here. And it's just a matter of undoing these two screws and replacing one mount or one fan duct for the other duct. There is a spot to be able to run 2 screws and some supports. So there's a screw hole there. You'll have these support spacers that will make it a little more rigid connection. So you'll have the connection back here and the connections right here in the middle that will attach to the bottom of our spool head carriage. And these spacers slash standoffs will help provide the additional rigidity we'll need to be running the beacon reliably, so this isn't just flopping underneath. So I'll be doing that. I might not do that here. I might do that off stream. Well, maybe we'll see. I got to figure out what size screw I need. Adjust the fan height based on the actual spool head. We are running the Goliath. I believe these are the correct spacers to use with the Goliath. Like I said, I just need to figure out, let me figure out how big those spacers are. That'll let me kind of gauge what the screw size would be. $16 millimeters. 16 millimeters thickness of this piece, which is 2 millimeters, so that's 18. So we're going to need at least a 20 millimeter M3 screw, preferably a flathead, the ultra low height flatheads that we're using, because the screw head's going to come up through the bottom part, through that spacer, and into the bottom metal part of the carriage. But we're going to be putting 2 heat set inserts in here and adding a beacon probe down here. So I'm not sure what that height distance is, and using those ultra flat screws, which I may have to order, would be needed. So that's why I'm saying I may swap that fan out a little bit later, because I do not believe I have any long length ultra flat screws like that. I have button heads. Yeah, I have button heads, which don't stick up a tremendous amount. But at the same time, I can't remember off the top of my head whether they use button heads or they being Steve and ModBot, or if they went out and got something else. So we will be making that fan change. For now, I'm going to turn this around, because I believe the next up, we are not mounting the 5015 fan. We are going to be using a CPAP system here. Hence why we have a kind of a tube shape here versus standard 5015 fan mount. Like I said, I did install the tri-horn. Here you'll kind of see where there's a spot for some spacers. Similar type thing, except ours are going to be right in the middle. And there's a space. So like these 2 screws that we're seeing, go full screen, easier to see. You don't follow instructions on me. There's a lot of, by this point, there's a lot of things I can intuit and just keep going. but there are some things that, I have to unbuild and rebuild correctly sometimes when I do that. But on this bottom plate here, you'll see that there's these two screw holes right here. These are threaded holes. And these two threaded holes right here have same threaded holes on the front. And that's the ones that we're going to use for those spacers to support having that added weight there from the beacon. Doesn't talk about it there on the Goliath. So on the Goliath, it says Goliath is using a nichrome wire to heat up the block. It's quite stiff, but also bendable to the desired position, but be extremely careful when bending. Be gentle, take your time, put your thumb where the nichrome wire exits from the heat block to hold it in place while you're doing your bending so that the wire doesn't come out of the groove. Yes, this kit comes with the Goliath, and we are going to be putting the Goliath on there. So this is our, whoops. So this is the Goliath hot end. There's two versions. This is the air-cooled version, and there's also a version that does water-cooled, but ours will be air-cooled. We do have our little fan shroud with the VzBot logo or the VZ logo. This is going to snap on to the top, and these screws will go right into the mounting plate that we'll use to mount into the 4 holes on the top and then mount it to the actual printer. Now, what they're talking about on the nichrome wires, let me remove the sleeve here. So this is the wound nichrome wires. So these actually get extremely hot. They're pretty stiff, and they're embedded into the wire channels. And you do have the ability to take and move these a bit, but you want to make sure that you put your finger there if you're going to move and adjust them. Sorry. You want to hold your thumb right here to keep it from popping out as you move and adjust these wires to where you actually want them. So, and then we'll have a spot for a thermistor that screws in here. Once we get it mounted, we'll get our sleeve on here, and then we will screw in that thermistor down the road. That back off. Now, there's 3 positions that you can use for the heat blocks since there are 3 screws on the standoff. So once again, there's 3 standoffs between the lower and the heat block, and that allows you to twist and clock this different ways, which means your wire and stuff, basically it changes where your bolt pattern's at. So we may wind up having to play with that a little bit as well. This, while it looks like this would be a super volcano, it is not. If you look down on the inside there, it uses a standard V6 nozzle. So I have a 0.5 and 0.6 Sliceworks vanadium nozzle coming from KB3D. And I have a 0.4 and 0.6 Undertaker nozzle coming from West 3D. So I've got options. Speaking of options, we also have our Duncan run here now. So since my Yeti cup will stay warm for a long period of time and that won't, I'm going to pop the lid on the Yeti and scoot that to the side for our secondary cup later on in the stream. On the VZ print head, you can either send the nichrome wire through the back under the print head. There's an option to run it underneath through the back or out the side. Sending it to the right will keep the neutral bend of the wire, that is my plan. It is recommended to add thermal paste or grease between the heat break and the heat sink for better heat transfer. So what I did off stream, I'm glad I did, is pop these 3 tiny screws out. You've got to take your 2mm driver and apply pressure in, because the hex head of the socket screw here is not the full height like you get on a normal screw. It's only like half height or third height. So you have to push in on your screw to be able to unscrew it. So you got to be very careful there. Once you take these 3 screws out, the heat sink comes off the heat break. I used 1 pair of Nippics down at the bottom, a smaller pair at the top, to make sure that the heat break itself was fully tightened. And then the piece of the heat break that comes up here, I put some thermal take thermal grease paste compound on it. Brought it all the way around, making sure not to get any at the filament entry side. So I got all that wiped around, and then carefully put this back on, making sure to kind of wiggle and shake it as I did so. So I didn't just push that layer of grease all the way down into this bottom. And you do not want to use boride nitride. It specifically states in here, do not use boride nitride. If you do, you're probably going to be getting a whole new cold side and heat break, because it's going to solidify in there over time, and you're not going to get this the cooling fins off of the heat break without most likely damaging or snapping the heat. So just be forewarned there. There is some no-name thermal grease included in here. I chose not to use it and to use my thermal take. I also had some Arctic silver around here somewhere. It is perfectly fine while it's not rated for, like, 300C like the hot end itself is. This portion, if it's hitting 300C, you've already got a problem, right? Because there's going to be a small fan blowing on it. And if this area up here is 300C, if your cold area is 300C, yeah, you've got a runaway heater issue, and you're going to have a lot of other problems before it gets that hot. Heat creep to the extreme. You can add heat insulation sleeve. What they're talking about there is for this gap between here and this rubberized piece. This may still get hot. You can add some like fiberglass insulative sleeving over here if you have it. If not, you can possibly wrap it in Kapton tape. But right now I'm going to leave it bare. I may wrap it with some Kapton tape because I have that readily at hand. So correct. And any ABS parts would be melting by that point. Yep. So if your fan's melting off the front of your printer, you'll probably have some heat creep issues. If your hot end, so a while back, Nero 3D, who's in the process of rebranding over to the Canuck Creator, he he brought out Toasty Boy, which is one of his older Vorons. I'm trying to think if it was I think it was a 2.4. And he was trying to print with Ultim, which is PEI and a peak. And he literally melted his hot end mounts, and the hot end fell off on the build plate because you're printing that stuff well above 300 C. So yeah, he had good chamber temp, and his hot end mount literally melted off the bolts. That was a funny one because that was on live stream too. Make sure everything's tightened properly, blah, 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 nozzle and heat break. Always heat the hot end before removing the nozzle, where you heat it up, move it with filament. Preferably, if you have one, use like a plastic pusher to make sure that you've pushed all the filament out, or at least down into the nozzle, so that you don't have any. What you're trying to make sure that you're clearing is that joint between the heat block and the nozzle itself. Yeah. You need a 100% metal printer. For certain applications, yeah. That's why there's not very many kits, or I don't know of a kit that's designed to print Ultim and Peak, because you must have a chamber heater to get up to the heat required to keep it from warping, and you will need a lot. Like, you don't want any printed parts on the. Not going to do. Always torque the nozzle after you've heated the hot end. Torque requires between 1.2 and 1.4 Newton meter. West 3D, I also ordered a torque wrench from them. He has a link in the instructions here to a tool to go out where you can print one. You got to be careful when you do this, because it's the torque you get out of it is very specific based on the materials you use. So we go through here. Turbine propellers are 1.2 millimeter thickness and provide a torque of 1.3 to 1.4. You'll need a few things here, but second here. Okay, so they're talking about PLA for this material. So that's where I'm saying you got to be careful. Some of these are specifically designed to use ABS to get the torque that they're calling for. Right? What I did was I went ahead and ordered, I believe it is a Zombie, correct me if I'm wrong, I believe it's a Triangle Labs torque wrench, but you can get it in one of 3 different torque settings. Okay, one of 3 different torque settings. I also have, they call it a Fat Boy, but it's for guns, and specifically torquing down fasteners on guns for like sights and Picatinny rails and things like that. I could use that, but it's about that long, and that's without adding the socket to it. So, yeah, I'd have to have the bed all the way down to be torquing it. But, yeah, there's a BQ one, but the BQ one, which is I think the Crab, nowhere did it tell me what the torque value it torques to. So, yeah, the Slice one. The Slice one states that it does 1.5, and this says to stay between 1.2 and 1.4. So you got to you gotta I mean, 1.5 shouldn't snap or foul the threads, but especially if you're doing like a tungsten nozzle. But at that point, I'm curious as to whether or not the tungsten nozzle threads will mar the threads in the hot end in the Goliath itself, you know? But I want to say the Triangle Labs one, you can get it as either a 1.4, a 2.2, or a 2.4 torque rating or something like that. So, yeah, you have a printer, so make one, Evil Diesel. Exactly. He's got several printers, and I know he has one that can print, at least one that can print ABS. A single tool that holds the hot block and removes the nozzle all in one. So we do this. I think it's, no, I don't want the hermit crab. There we go. The BQ crab nozzle changed. So the top portion of this is made to be able to hold the heat block, while the bottom portion holds one of your sockets, and it comes with several sockets. Do they show it? Yeah, here you go. So this is actually holding your socket. So you got one piece that holds the socket, your other piece slides up into it, and then you can just, then you just use the one hand to take it off. But the problem is this doesn't tell me anything about torque ratings. And if a printer or a manufacturer gives me a specific torque rating, I want to try and use said torque rating. So I don't over tighten and bust threads and cause leaks, right? But this is an option. Just realize that the torque rating may be in your hand, or it may be listed in the physical product packaging that you get. But it comes with the different sizes of sockets. So if you don't have metric sockets already, that's not a bad thing, and it supports a bunch of different ones. So anyhow, onwards and upwards. Use it for, exactly. I mean, 1.5 should be good. Yeah, Evil Diesel, check. I'm trying to think if it was West 3D or KB 3D that stocked that. I think it was West 3D that stocks it. I think KB 3D only had the Slice Engineering one, but which is 1.5 Newton meters. 1.5 Newton meters of torque. Okay. So same applies for the heat break. It tells you how to basically put things on, take things off. Now what we need to do here is we've got a mounting plate for our Goliath. We need to mount this, and we flip the printer around, move it back. We'll have some room over here to work. Get this over slightly. Mouse up out of the way. So what we're going to be looking at is how do we get our 4 screws onto our Goliath with the wires coming out the right. And that's where it may be easier for me to get this mounted, because I can either go this way and it comes out the right but towards the back, which would not work, or I can go this way where all my screw holes line up and it's coming out the right but kind of to the front. Well, it's more front. So this plate is going to go in this way, right? These little wings go towards the front. So we don't want the wires to be that far clocked in front. But if we move it around, like I could clock it that way, but I'm only getting 2 screws in. That's not good. So that's where I'm saying I'm probably going to put this on, and then I'm going to undo these 3 screws and work with playing with the clocking until I find the right clocking to where the wires are coming out the right direction. And there could be the ability to actually push these wires back a little bit more, because you notice it's kind of sitting proud of that bit. So I might actually be able to push these wires back more and bend them. See? Yeah, it's so much easier when the thing that you're trying to push against turns in your hand. Yep, no, this is going to be easier to undo these screws. So and once again, the screws that they use, the hex head of them is not the full height of the screw. Head is kind of hard to explain. So you got to make sure that you push your driver all the way down in there and give it a little bit of pressure to pull it out. Oh, wow. Hey, Ash Prince, welcome on in. Stephen Poole, MakerMind Nexus, welcome, 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 sir. Good to see you, sir. I hear you have a new bamboo in your office. Was that for you, or do you need to test it before it finds its new home with a student? The kind of what I'm doing right now is just clocking. This brings it kind of almost vertically back. Rotate it one more time. See about where that gets us. So that close, but still not there. Might be the best place we're going to get it. Like I said, we may have to apply a little bit of persuasion to our wires. Dark Golem, welcome on in. Yours of them now, but one day, maybe, who knows? I hear you. And I want to say these are like 2.5 millimeter screws. They're either 2 or 2.5 millimeter actual screws. So you got to be careful. You want to kind of give them a little bit of a nugga-dugga, but be very, very slow and careful that you don't strip those threads on that there. I think, make my life easier, I'm going to at least snip one of these. I can get a little more working room here. We're going to need the M3x6. Hey, Timur, welcome in. Yeah, he's got the MMU2. My MMU3 for the Mark IV has arrived. We're not going to be working on that. I don't plan on working on that prior to Midwest because, let's be honest, we've got black box and a couple of other things that we need to work on. So this stick is not going up or down. I think we're about going to be done with this stick. Order a new one. So I was using Prusa Slicer for everything. Now I have switched and I'm using Orca Slicer pretty much for everything in my stable except for the Prusas, which are running Prusa Slicer, and the Bamboo, which is running, oops. You know what? I thought this was M3. This is not M3. These are M2s. I think that was M3. These are like M2s or M2 point. Let me, what do we got for that? 5. Most likely 2.5s because those we've got in that ultra low countersink style. And there's 4 of them. That's going to be what we do for that. Yeah, so I primarily use Orca Slicer, which is, you know, a ported version of Orca. And I'm sorry, ported version of Bamboo. I'm using the Bamboo Slicer for the Bamboo right now. I know I can just use Orca Slicer. But the issue I've had is as soon as I log in with my Bamboo account. So yeah, to do some things with the Bamboo, you have to log in with your Bamboo account. It does weird things. We'll just leave it at that. Sometimes it's easier just to use the vendor solution and roll with it. Also, the belt printer I use Idea Maker for because the only option for a belt printer is going to be Black Belt Cura, which is like super, super old, or using somebody like having to install like 4 or 5 different scripts that post-process stuff from a newer version of. So it's easier to use Idea Maker. The Ender 3s work on Orca? Yep. Yep, they work on Orca. especially if you switch them over to Clipper. Because one, well, your ender's just going to run better. And two, by the way, Zombie, thanks for the wonderful idea. That wonderful idea was Pex Peppers, the was it the Pueblo sauce on the on pizza. That was good. Now if I can just get the rest of my Pex Pepper sauce that I ordered from your stream to come in. Yeah, quite honestly, I had Octopi, you know, running on a bunch of stuff. Then I started clipperizing things. I would run Octoprint on the Prusas. Then I just bought the ESP modules and flipped them directly over to, or at least the mini over to Prusa Link. Now I've got them on Prusa Connect. So, which is basically Prusa's cloud, which works well. Okay, so there's our mount with the 4 screws. Ah, so you got a Libra board, did you? So the person you want to talk to about that Libra board would be MakerMind Nexus over there. This little bit of a hardened chunk off the top here. Just make it a little bit easier for the next operation. Okay, so we got that installed. That back over there. We need to cut some PTFE tube, and we need 22 millimeters of PTFE tube. Now, I have been going through and using this to be able to just lay my tube in there and get a nice straight cut, and that works well. But, you know, there's this guy. This guy's name is Steve, and he likes to build things. And, you know, he always does things that winds up making me do things because it's cool, and I want to be one of the cool kids. So give me 1 second to put in a heat insert on here. And we'll have to do over here. Very carefully, of course, since I'm now doing it over the carpet. And off camera. Sorry about that. So Steve builds things, and he creates these cool little tools and jigs and prints that we use for all kinds of stuff in our builds. And one of those things that he has created, specifically to help him out with the various builds, is a PTFE cutting tool. So it's a quick print. It's a real simple print. And then all you need is a heat set insert and an M3 screw to be able to clamp your PTFE tube in here. I grabbed an 8 and Apparently going to need at least a 10. You make that probably a 12. Work. There we go. This, that down so you can see what I'm doing. And I need to find PTFE tube that came with the kit. Okay. Still not there, still not there. There it is. We found it. Okay, so we got our PTFE tube. This looks sort of Capricornish. I'm not sure if it is, but what you can do is you put your tube in the one side. Try not to have it clamped too tight that you can't get your tube through. Or apparently maybe have a may have just a bit of elephant's foot there. So give me 1 second to grab my 4mm reamer. Clean that up just a tad bit. But the whole point is you'll be able to get a nice clean edge on the one side and then flip it around and set your PTFE in, find the right length, and cut your tube. That way you get two really nice ends to your PTFE tubing. You're going to do your first ABS print on the flying bear. Nice. Make sure that you, when you go to do that, Evil Diesel, just make sure that you let it heat soak for a little bit with that tent on. You're printing your new printer. Sweet. Also, if you look at this end right here, you can see how it's kind of crushed and ovid. That's because they cut it with just a pair of snips or a pair of scissors. And that's what the other thing that this tool is going to do is to keep that from happening, where you don't get a crushed end, you get a nice pretty end cut. And that's what we're trying to do here, is we're going to make sure and we're going to put this in and just run it through a little bit. We'll cinch this down just so it doesn't move out. Then we're going to take our blade and go right across the top or the bottom of this flat surface that we printed against. And that's going to enable us to get a nice, clean, flat cut. Okay. Very nice, very clean, very square, and it's still round. Okay. Now what we're going to do is loosen that, pull our tube out. We know this is our good cut end. We're going to put it back in from this side now. We'll just put it in a certain ways. We're going to grab our calipers. Now, the instructions say if you run the VZ Hextrudort, which we are, CNC version with the VZ print head, PTFE between the Goliath and Hextrudort should be 22 millimeters long. Watching Steve and ModBot do their build, Steve actually did some measurements, looked at the CAD, did some more measurements, and said it's about 23.5 millimeter, right? So what Vez kind of recommends in his video is to cut it to 24 and then just keep trial fitting it, shaving a little bit off at a time to make sure you get the proper fit. You don't want to compress it, because if you compress your PTFE tube, it shrinks the inside hole, making it even tighter, which is bad. What we're going to do is we're going to turn this on, zero it out. I'm going to measure out 23.5 or thereabouts. I'm about 23.38. I think that's going to be good. Locked my caliper. Then what I'm going to be able to do is, with one end right at the back here, the other end at the top of the tube, I should be able to pull this through until I'm at the right measurement. Do something just like that. Without moving it, we're going to lock this screw down. I'll lock that tube in there. I'm going to verify that it didn't move. So once again, we're right there. Now, once again, take my blade and cut this off right using the back edge, the straight edge of this piece. And that'll give me another clean cut edge. So we've got another very nice, cleanly cut edge. Now, before you do anything else, before you take it out and make it any harder on yourself, this is the deburring tool I use. I use this for doing all of the aluminum for my airplane and deburring all the holes on my airplane. This is the easiest thing to do. Any oversized bit or specific deburring bit can be used for this. You're going to line that tip up in your tube, and you're just going to give it 1 or 2 light turns. You don't want to do too much. You're just trying to make a little bit of a chamfered edge there. Probably not going to focus for me because this print has a shine on it. But we're just trying to get a little bit of a chamfer on this. It doesn't need to be a lot, very little light pressure. And then if you need to, because I see a little bit of a chip or splorf in there, just use a pair of tweezers to pull that out. I want to make sure that none of that thread gets in there. and so that we have a little bit of a chamfered edge. And this would be the edge that's going to face the underside of our extruder. Okay. Now, I prefer to chamfer both edges. And the reason I do that is because I have found that as you print, you know, if you're not using a filament cutting system like the Filametrics or the AMS, well, you get a little ball at the end of filament. Do I have one here that has? Yes. Do you see the end of that? How it's got that little bit of a ball at the end of it. That's because it was melted and then re-solidified. That ball can get stuck, especially if you're using the tighter tolerance like cap tubes. That's why our reverse Bowden tubes, we always use a 2 millimeter inside diameter. But for the section between the extruder and the hot end, we need it to be constrained. We don't want a loose fit for that. We want a loose fit for the reverse Bowden tube from the top of our extruder to wherever on the printer. Right? We want that to be loose, but from here down to the hot end, we want it constrained the whole way. So I just flip this around and I'm going to do the same thing to the other end here. And just very lightly, 2 or 3 turns. I'm not trying to do anything major. I'm just trying to basically break that edge and give it a little bit of a chamfer, just to make it easier for the filament to properly feed through. And then what you can do is actually take a piece of filament and run it through all the way through both ends several times. And if you've got any type of burr or a piece of that PTFE that fell down into the tube, that'll get it out. And you just want to make sure of that because you don't want any PTFE to get into the melt zone of your printer. So get the blade out of the way. I cut myself on stream. Get that enough off stream. Not on purpose. It happens. Okay. Undo this. We'll take that little bit of PTFE tube out. And we may have to redo that end a little bit once we go to put this up there. But you're going to take that PTFE tube, pop it in, push it all the way down. And then we will be working to mount this on our printer. That tube lined up. This is where we're going to have to bend the wires a little bit, possibly. Tube lined up. Push it up. And you'll see that I'm not getting a good seat. That's because these wires are kind of pushing me out and forward. So we're going to have to do something with these wires. We still need to kind of bend them out of the way a bit. Gently. Ever so gently. You can add some bend to it. You just don't want to pull it any further out of the edge there. That PTFE tube back there. Back up. That's still just for giggles, I want to turn this around, and that is the right way to mount that. Maybe I do want this to be coming out more towards the front and then bend it naturally back around. Let me go ahead and work on that. Yeah, so I have printed the parts for a Tugboat 3D Rook 2020. I was gonna give them my salad fork, Dan, and then Woohoo Sam came up and offered me a Picado HE50, an FXD extruder, and an ERKFA V2 kit for the salad fork, and I caved, and so I worked a deal, and I have printed all the parts for them, and tomorrow I still haven't done it, guys. I apologize. It's been a nightmare with work right now. But I'm going to be cutting the frame with the extrusions I got from you, Dan. And I'm going to cut 2 frames and do all the drilling and tapping myself. Because right now, DLL PDF, I believe the story that I have heard is their kiln is no longer working at the moment, or they're having to get it repaired. And they're at least 30 days or longer behind on orders. So, that being said, I'm going to cut the frame rather than trying to get a DLL PDF frame. So, this one, lock it more toward. That's way clocked. That's because. Back. The end result is it needs to be clocked towards the front. Be able to clear the way But yeah, and I showed you guys on Tuesday's stream that I did get the clone bamboo hot end and a clone HGX, like the large gear extruder is called out in the bomb. I did buy those off of Amazon versus trying to get them from AliExpress, just because I get them here a lot faster than ordering them through Ali. So we've got that. I'm looking for the Morn Sun LMF power supplies, and if I cannot find them, I will have to reprint a part for both of us, because that means we'd have to go to using the external power bricks. which is doable. I've got my original Rook did that. Okay, so that want to bend this back. We'll work on bending this more and better afterwards. Right now, I just want to get this lined up and mounted. This is going to mount right here with 2 screws coming up from the bottom. And that's where we'll see that our fan needs to really come down a lot. You see how, or I'll show you how long these, or how much the length of this tool head is. It massively. Does it say, does it say, this is an example of it going backwards through the tool head or underneath the tool head. And this is kind of an example of it going up to the right and around. I think it's a little bit better to do it that way because it's more in line than going towards the back. Towards the back is doable, but I'm going to go ahead and drop my fan mount. Figure out the final and correct height on that a little bit later, but we're going to need to get it down and out of the way. So we should be able to run that wire directly back if we wanted to. I kind of like the idea of about running it up and around the side. Sorry, folks. M3 by there's also going to be the fan mount. So I think this goes M3 by 8s. Go ahead and grab those. Make sure that I get this installed as well. I have the fan mount that's going to pop on here. It's going to come in from the front. That, and it has the little printed piece that pops right there into that groove for alignment to keep it from turning. Again, we'll work on bending this around later. I'm going to go like this. Then our M3 by 8 screws, so one on each side. Through the plastic fan mount, through the other mount, and then into the top plate. Threaded. One side, side. Zolan's on. He's on YouTube, isn't he? MakerMind Nexus. I am sure there might be a cut system option or mod for the Prusa head. Wouldn't be a bad thing. All right, cool, Tugboat. Yeah, and after we talked with, I had Chris come over and we chatted a bit. Thing is not lining up. Yes. So KB3D walked over and we chatted with them, figured out what it is that they were needing the printer for. And once we determined that it was, part of their goal is to go forth and teach elementary students about 3D printing and 3D design, then it was kind of, we'll say, on like Donkey Kong. And the end goal is they need a printer that they can take into a school and is easy to transport, right? So an Ender 3 is a good printer, but it's a little bit bigger, it's a little more unwieldy, it's a little heavier, it's harder to move. The Rook is very, very portable, very easy to move. The fact that it's an open air printer is just fine because that means that, they'll be using PLA anyhow, which is a good thing for, doing stuff in the schools. So all in all, it works out well. There we go. Bada bing, bada 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 boom. And quite honestly, now that I look at this, there are 4 direct mounting holes. Oh no, that won't work. I was like, there are 4 direct mounting holes here. However, these 4 direct mounting holes in the top plate would only be useful if you were doing Bowden versus direct drive. Sorry, folks. And I say that because the holes aren't countersunk. Okay? Which means any screws that you go from the top on are not going to be flush with the top of the plate, and your extruder needs to sit flush with the top of the plate. So, yep. I'll say a Rook 2020 is better and easier to transport because of its frame. You can literally grab it by the frame, pick it up, and move it around. Where the Rook 2020, or excuse me, the Rook, you got to be a little more ginger with it, right? So that's what I like about the Rook 2020, and that's why we're going to get them set up with the Rook 20. So once again, we'll be able to work on bending this wire around, which will probably be a little bit easier now that we have it rigid mounted. And we'll be able to bend the wire itself up and loop it around and do something like this. Okay? And then you'll take your sleeve, because that is not a full slot there, you've got to put this on before you put your thermistor on. But here's the problem. You got to have a thermistor in it before you can heat it up, and you can't hot tighten it with this on there. I mean, you can probably if you're very careful. So you should be able to do that, but I mean, it's got the flats down here at the bottom, so you can hold it here with one pair of pliers and torque your nozzle on there. Because if not, you're trying to torque these threads. That's a long moment against these three small 2.5 millimeter screws. So find where this matches up. Throw your sleeving on there. Sure it's twisted around properly. Silicone socks are a pain in the tuchus sometimes, because you need this hole to line up with the hole where you're going to be putting your thermistor. This is definitely something you're going to do while it's cold, not while it's hot. But you need the sock on before you screw your thermistor in. And of course, you'll need your thermistor in to do your heat tightening. So it's more like you'll have it off, you'll do your heat tightening, and then you'll let everything cool down. You'll take the thermistor out, work your sleeve on with everything cold. I see. Catching the back sleeve on the carbon fiber tube. But anyhow, I'll play around with this a little bit off stream. Won't keep. I say that as I continue to fiddle and futz. Pretty close there. Not all the way up though. Oh no. We'll continue. I'll play with that after stream. So we've got that done. This over here, this down there. Need this anymore. Okay. So we now have our tool head pretty close to done. We'll add our nozzle once they come in. Once again, I've got a couple of vanadium nozzles coming in from KB3D and a couple of Undertaker nozzles coming in from West 3D. So, yep. We're told your config on GitHub has helped a few people, so that is awesome. Yeah, I'm pretty sure I got my config on my GitHub. I just haven't made it public. I should probably stop being a dork and do that. So the other thing I just noticed is the way I've got this clocked is my thermistor is going to be coming straight out the front. I will probably be taking this off and playing around with it again to get it. I think I'm going to have to clock it again is where I'm going. I'll do that off stream after this. So we can probably, not probably, we're going to have to drop our fan down even further, most likely all the way to its lowest position. For our Goliath, if you are running a like next G extruder or a Rapido, it probably wouldn't be all the way down, especially if you're running the next G without the extension, which quite honestly, I would be running the extension on it, but that's me. We got that pulled down. There is a pillar brace, which is a little 3D printed part. Got a little cutout on it that fits down on the back side of the pillar that just covers up things and gives that brace a little more, I want to say protection, but just a tad bit more rigidity. So kind of a tight fit. I have to do a tiny bit of sanding on this, or filing. Make sure that I can get it down in there. I want it to be somewhat tight, but not overwhelmingly tight. Could also very much be the fact that the screws that I have in there to hold that in place are kind of sticking out a bit. Back this lower screw out some. See about putting this brace back there. Nope, it needs to be squared off. So sides of this brace are printed at a slight angle, and I have a feeling that this brace works great if it was printed parts versus a CNC part. It's not required, it's optional. So I'll play with it a little bit, but if I can't get it here in another trial fit or two, we'll just proceed. Yep, and that's what we're going to do. We're just going to proceed. And if down the road I feel like it needs something, then we'll figure out some type of support. I mean, moving the whole printer by it. Probe options are here. We're going to do a probe on it. It's going to be the beacon probe. I'm going to swap out the tri-horn, and we'll work with that. Where are we at now? Switch back over to the Adobe Acrobat build manual. Yep. And belt tensioning. One of the steps of belt tensioning calls out energizing the motors, because you need the motor to find its step. Right? We can't do that until we have the electronics in place. So we'll get minimal panels on, and then we will go through and get all of our electronics and stuff done. And then once we get our belts and stuff squared away, then we'll work on the rest. So just like we'll work on also getting our build plate and stuff added on after the fact. Going to keep that out of the way. There is one thing that we need to do, and that's we're going to scroll back up a bit, and we're going to put our little front side panels on here. Somewhere over there. Here we go. So we'll have the small side panel piece on each side. And I believe those are going in with M4s. And so we're going to have small side panel. Okay. And there is a different cut pattern. So this side got one hole, the two holes for the hinge piece. On the other side, you've got two holes, third hole, a slot, and then the other hole at the top. This is the top portion that's going to line up over here. So the single hole is going to go over our tensioning bolt. The other one has a slot to make sure that we get everything else in alignment and it can line up on the printed part there in that M4 bolt that we put in. So all of these are going to be M4 hardware. And let me check the CAD real fast to see if it calls for hammerhead nuts there, or if it calls for using our M4 roll-in T-nut. Answer to that question is still up in the because it does not say. So we're going to go ahead and I'm going to put in the roll-in T-nuts. And because I've got the ability and the space to do it right now, I'm going to lay this on its back. So that I have gravity working with me and I can lay things out as appropriate and get all of my pieces that I'm going to need lined up. Once again, it's going to go on like here. I'm going to need 1, 2, 3, 4 T-nuts. Actually, looking at these, you may do hammerheads. I think I had M4 hammer. Yeah, 74 pieces of M4 hammerheads. That's probably going to be the better idea for all of the panels. So I've got both M3 and M4 hammerheads, which, like I said, I think are going to be a better idea for panels. So, and these are 3mm panels. So I'm assuming These are going to be M4 like 8s. Would normally be what we would use. Maybe 10s. 50. And I'm going to say 10s because I don't have that many 8s. I have like 2 8s. We're using our M4 10s, hammerheads. Be checking to make sure that we don't bottom out. And will bottom out. These are, that's a 4. That's a 4. Once again, a 10 is going to bottom out. This, the top and bottom are going to be an M3, not an M4. So I need an M4, but I'm going to need M4 by 8. 10s are too long. Nothing about putting a I only have 2 M4 by 8 button heads. So this is one of the things that I'll say the frustrations that Steve and ModBot were talking about was the inconsistencies in the amounts of screws, inconsistencies with the CAD, just in the simple fact that like I'm looking at the CAD right now, and it looks like it's got, screws and fasteners, right? But normally in CAD, like on all the Vorons, you click on that, and down at the bottom, it would, in the bottom right corner, it would tell you what the screw size is. Each one of these is modeled, but it's not a, well, actually that one just did. That says it's an M4 by 10, but an M4 by 10 on that panel. Oh, you know what? Nope, that makes sense. It is an M4 by 10. Because I forgot there's a piece of plastic that goes on there as well. So I'm sitting here starting to get upset, and it's really, I'm getting forgetful. We'll call it that way. Getting forgetful. It's up to you, Tugboat. If you've got the setup to do it, we can definitely do a live stream. If not, then I can always do a stream, and then you can follow along or whatever. It depends on if you've got a setup. It doesn't even need to be a camera on you, but if you have a camera and mic, we can do that. So what I'm forgetting is, like, hey, there's actually printed piece that goes right here, right? So I forgot that printed piece. So if I add the printed piece in there, I'm gonna make up the difference, and I will have the 10 millimeter or the extra 2 millimeters of slack. So what I'm gonna do is I'm gonna get the printed part. Let me switch the screen again. So we've got the printed part, the clear plastic, and then once again, I'm going to do a hammerhead T-nut here because it doesn't tell me which fastener did you use where, right? And that's one of the downsides that we're having with this is it. And by fastener, I mean, is it a hammerhead or is it a roll-in T-nut? Some places the roll-in T-nuts have been extremely difficult to get in. Other places they pop in no problem. So it's just been kind of painful and interesting all at the same time, getting things lined up. But we've got that in. We'll do these two, and then we'll have another one that goes into the front here, which I believe is a M3 by 10 as well. Nope, that one's an M4 by 10. It's actually an M4 by 12 for that one. We need to find our M4 by 12 button heads. We kind of need a mixture of 10s and 12s. Now the front screws, the turn, I'm going to call it like a turnbuckle, our tensioning mechanism, it's going to use a printed knob with a nut. And one of the issues that we're going to have there, besides the fact that I don't have said printed knob and nut, because the printed knobs that I thought I had printed out for this are actually for mounting the bed. They're the M3 for the bed, not the M4 for these. And you're going to have the nut that you're going to put an M4, or excuse me, you're going to have the knob, you're going to put an M4 nut in it, you're going to screw it down, and then you're going to have these caps that press in. So I'm going to use the lime green for the knob, use this as the press in to do the accent piece to it. But, okay, so a couple of more M4 by 10s. The other printed part. Pins, some hammerhead T-nuts. Oy. Hey, Shenanigans, how's it going? Welcome on in. We are over here trying to continue making progress on the build. We're putting our front panels on that we did not put on beforehand. We've got our tool head initially installed, so I think I'm going to have to take it back off. We'll do that off stream and block it a little bit differently so that where the wires come out slightly different. And then the nice thing about this setup is your tensioner knobs are external to the printer. So you can tension without having to open it up and do everything to it, which is nice because that's one of the things that's a bit of a pain on a Voron if you ever have to go in and revalidate the tension on your belts and stuff. Just kind of gets in the way. So get back over here. We've got these done. I need to print the right nuts for these motors. We'll get that printed out. What did this just... That was my tightening bolt from underneath here that apparently was too loose. Right. What's going on there? So half a second. Try and figure out what's going on with this bolt, why it's not happy. Might be the fact that it's screw that it attaches to may have moved. Sure, but the peanut itself that it... All right, there we go. There we go, got that corrected. Get this set back up on its feet, or on its base at least. So we've got this fixed. Did this on both sides. We still need the tensioning knobs. We'll hold off on doing the pins and the front door hinges because there's no sense in having them on just yet. We do need to add the Y end stop at some point. We added the X end stop, at least the mount for it. We'll need to, fill up the wires and stuff for it. Any plans for a deconstructive stream? Deconstructing of what, Nick? I have plans to completely take apart and rebuild a TiVo Tarantula, which was my very first 3D printer. I have plans to take apart the Boron V01 and rebuilding it as a V02. And I only want to take off the things that I need to down to the bare, I don't want to have to take it all the way down and reassemble the frame if I don't have to. Normally I print all the parts ahead of time. This particular build, I started off just printing the parts that I needed. And part of that's because this is a CNC kit. There's certain parts in the files that I don't need to print, and the GitHub for this is just very, very convoluted. So there are some things that I've printed or some things that I thought I had printed that I didn't actually print. I printed a different part. And so then that's kind of where we're at, is me trying to get caught up on the stuff I thought I printed and did not, or things that I didn't install initially that I actually needed to install. Going through here, going through here. I'm just trying to figure out where and which side I need to do the Y Endstop. Okay, so this is a front door hinge. So the Y Endstop is the front left is where the Y Endstop gets mounted. And here's the thing. We've got a printed part, right? Mounts up under the rail like this. The end stop mounts here with the piece facing backwards. So it'd be mounted like this, only on the inside rail here. Or we've got our other, and by other I mean our last CNC part right here, which will do the same thing. Once again, it's going to mount up underneath here with our end stop. And our end stop here is basically getting triggered by the actual carriage itself. Now this would take two M4s with, I'm going to use hammerheads for this. These are going to go on with, going to assume an M10. Just double check that M10 would bottom out. This will need to be an an M10, 10 millimeter long M4. So we're going to need M4 by 8s to mount this. And they don't necessarily have to be, these don't have to be button heads, but if you've got them, probably use them. Don't. So there's two M4 by 8 socket head screws in here. So hopefully I don't need these for anything else. Once again, this is a kit from Mellow. It came from, of course, Mellow store on AliExpress. The CNC parts are actually very nice so far. So this is the 235. There is a 235 and a, it's 330 is its big brother. And this is the 235 kit. I ordered it thinking, okay, this is going to be like, you know, normal AliExpress. It's going to take forever and a day to get here. It did not. I got notice from DHL because they ship via DHL. Expensive shipping. It was a couple $100. I think it was a couple $100. We'll take a look here in a second. But it, I got notified on Sunday that it was shipping, and on, there's some M3 or M4 by 8 button heads. We'll use those instead of the socket. I got notice of shipment on Sunday. They arrived on Tuesday. I say they, but the box arrived on Tuesday. I was shocked, to say the least. I have never ordered anything from AliExpress and gotten it that quickly. So I was kind of floored. And so that would be the other reason why I didn't have parts printed, because I figure, okay, I got ship notification. I've still got plenty of time before it arrives. No, it arrived well before I expected it. So I did still have some more M4x8 button heads, so I am going to do button heads on here. And once again, this is going to mount underneath the rail right behind the motor on the left side here. So I really don't have a good angle unless I just set this on its side. Even then, it's still not a good angle. It's going to be going right here next to that motor mount with the go like this, and the say the end stop needs to be on the inside of the rail and pointing forward. And I'm going to give it a little bit of room between the motor mount here, because once again, we're going to mount our end stop, and it's got the little legs that stick out behind it. So I need to make sure that I protect the wires with heat shrink. I'm going to have to, figure out what my wire lengths are going to be, do the soldering, protect it with heat shrink, maybe even cut down the legs on these a little bit so it doesn't stick out as much, so I can get the most forward travel as possible. But the Y end stop is now mounted right here. See that? Now mounted right here. We got the X end stop installed on here, which is a printed part. Why that one was not CNC machined, I don't know, but that is a printed part. Next up are going to be the bottom and the rear panels. So full panel kit is available, blah, blah, blah. We have a full panel kit. For the all-wheel drive variant, the rear panel must have cutouts at the idler section. So this is our rear panel. What I'm going to do is kind of turn this around. And this is our rear panel. As you see, we have these cutouts on each side that line up with the idlers. And that's to give us the ability to do the synchronization over here. We're going to have the spot for the two big fans. This is going to be our ventilation. The V's symbol goes on the inside. I'll actually go like this. So this will be for our exhaust, right? Ventilation, the exhaust. This is going to be for our CPAP. Once again, the cutouts for the access to the idlers. We'll have grommet spaces down here at the bottom, as well as one right here and right here. And these will be used to bring wires through. This will be the wire for the Z motor. I'm not sure what these two are for. Our other motors should all be able to come down, route in, and through the middle here. So we're going to go ahead and get our ASMR peel going here. This is so much easier to do with like a 3mm panel. I had to do the same thing on very thin sheet stock for the airplane, and very, very difficult sometimes to pull all this stuff off without bending or buckling or stretching like a wing skin. A lot easier on panels like this that are pretty thick. There we go, one side off. Go ahead and get the other side off. Same type of thing. Now, luckily, in watching VzBot and Steve's stream, both of them had like some mangled corners or like a gash in their plates. And all of my corners seem really good. The slight burr, I may go through it with my deburring tool and clean some edges up a little bit more. That's more of a me thing. Definitely not necessarily needed, and especially not on, I'll say like this hole, these holes down here. I think that hole as well. And I say that because I 3D printed, yes, I did 3D print grommets. So TPU grommets. Just don't know where I put them at the moment. Because I do need to clean them up. You know, I printed them with a brim because they are pretty small parts. So I do have to clean the brim off. That wasn't it. I probably put it in one of the other bags. Not a problem, not a worry. We're not going to need that right now anyhow. Now, a couple of things that I do want to be cognizant of, and I know this from watching Steve and VzBot, are there certain holes in here that are covered up? Or there are certain holes like this one that's going to have a corner bracket on it. So you don't want to actually put anything in that hole right yet, because that's going to be another mounting point for the screw, or for the panel clips. Yeah. What we need to do, bring back the enclosure. Because what I need to do is just try and figure a couple of things out. So we're going to have screws here, screws on the side. Two of these are going to have plastic parts that that mount to them. These little slots right here, which has some nasty burrs in them, are where the two power supplies are going to get side mounted. They're going to come out this way, sit vertically, but come out this way. And then we cannot forget that we've got three that come along this back rail that provide some good support there. Once again, yeah, that's laser etched. That's not painted. That's a laser etching there. So what I'm going to do real fast is I'm going to grab my rotary deburring tool and I'm going to hit every single one of the screw holes on both sides real fast, just to make sure and clean up any burrs that are there. I don't want to mar my my extrusions if I don't need to, and I don't want to, we'll say, mar myself as we're going through and getting everything mounted here. So building my airplane, I can tell you that just going through and deburring all the holes and all the edges, and then of course needing to match drill some holes, and then deburr all those holes and edges and everything. Yeah, I have come home from doing that all day long, and my fingertips are just shredded. Like if I had to get fingerprinted on, if I got arrested and had to be fingerprinted, they'd be like, okay, why are you trying to obscure your identity? And the worst was the stainless steel firewall panels, because you still had to deburr those. But those edges were just super, super wicked sharp. I'm going to do all the screw or bolt holes on both sides, and then I'll come back with a different deburring tool and do the larger holes, the rectangles, and the outer edges. And once again, just like before when we were doing our chamfer, it's just one or two quick turns. It's not like you're trying to take off a lot of material. You're not trying to you're not trying to drill through it or make some really weird chamfer. Taking the printer out back a couple of times. Yeah, let me guess, Ender? Now I'm using a more traditional deburring tool that you're probably used to, but this has a bigger grip, which is a godsend when you're doing, like, I don't know, wing panels. You're doing several feet of edges. And I actually have one that has like a V-shaped head on it that you can do both sides of a sheet at the same time. This is good for just taking the edge off of these corners or the grommet holes, circles. All we're trying to do is break the edge. I don't know where we're going to have wire versus a hose yet, but the hose for your CPAP really is not very thick. So any type of sharp edge, and you can break that sidewall on your CPAP, and then trust me, that's going to make a racket. Once again, you can take your deburring tool, go to the edge. Just trying to take off a very minimal bit of material. If you get a spot where it feels like it's just where I'll say the cutter, when they cut the panel out, just got a little bit too happy in its job, take a file to it. You're not going to hurt these taking a file to the edges. Just open up the end of my tool and it was hanging up in my hand. And this is a tool that we're using to take, metal or plastic off. It is pretty sharp. You will slice yourself open. And this is what I'm saying. When I do this, when I was doing this for the plane, I did things like that all the time. Give me a second. I'm going to ask Mrs. Dragon to bring me a Band-Aid. It's not a good build if you haven't bled on it. Hey, Jedi Spidey, how's it going? One old Anycubic, yeah. So look up a TiVo Tarantula. That was my first 3D printer, and it wasn't an assembly. Like an Ender 3 is like a Prusa compared to this. Like you had to assemble this. So, and they had boards similar to an A-net where the like when I get off the phone with your brother, she's getting information on grandniece. Hey, ma'am, welcome on in as well. Just joined and heard Band-Aid. Yeah, I was deburring these edges because some of these edges were still a little sharp, especially the mounting points here for our so the mounting spots here for the power supplies. And I slipped with this tool and took it right across my finger, which is, of course, the pad of your finger is nice and soft. And you've got a tool that's designed to deburr metal. So, yeah. Don't worry. I used to keep big boxes at the hangar and like down in the garage and wherever else I was working on the plane. Yeah, deburring accident. So, yeah, in looking at these panels, and so let me switch over. We're going to look at the CAD real fast. Okay, so looking at our panels, it looks like all of the screws across the top can be used. So these corners, I thought we were going to have a bracket, but it looks like it does not have a bracket. So we can put something in all the ones across the top. We'll have these three in the middle that we put something in. We have two on the side. And then actually the two on the side, we have like this one right here that we can go in. And then the next ones right here and here. So these bottom two ones, based on the CAD, let me do that. And give me 1 second, folks. I'm going to mute you real fast. All right, and we're back. And she brought me knuckles instead of fingertip, but that's okay. We'll work with a knuckle one. We'll get it covered. Figure it out and make it work. Do something like that. Right. You haven't bled on your project. Is it really a project? So on the sides here, okay, so our power supplies are mounting on each side here, and then down here, we grab those parts, and I'll show you these guys. We're going to have these parts, and there's a straight side and an angled side. The straight side is going to line up with the edge of our power supply. And so this is going to mount on the side here. So these two are going to go through the plastic, through these panels and in. But the bottom of this panel covers up the bottommost screw on each side. So we can't put a screw in here, but we'll have one in the middle. I kind of don't like that. I wish that they had a hole modeled in here to cover that, or at least a gap down here so that I could put a screw in here, then mount this over the top of it. I don't know. I mean, it should be okay because we're having a screw here. If this amount of 3mm thick aluminum bends, you've dropped this, and you're going to have a lot more to worry about than this bent aluminum. So we just need to be aware. So pieces like this should all be able to get like M4 or M3x8s. The ones that are going through the plastic pieces are most likely going to get M3x10s. On this CAD, I am not seeing fastener. Like I'm seeing a hole. Oh, what is there a fastener there? Let me see if I can just this. Yeah, fasteners kind of go away. So I've got holes in the panel, not it's not actually telling me what screws are going. You see if I can't get, yeah, it's just showing me the holes. So we're going to have to kind of feel our way through. So that's one of the things that I know this started getting Steve and ModBot a little frustrated on their stream when they hit this stage, because like I said, there's, what are you using? I'm going to assume, just based on quantity at hand, that I'm going to be using M4 and M12 button heads. And once again, I want to make sure, just going to go through with an M4 and see if it fits everywhere. And if it fits everywhere, then that means M4 is everywhere. So I'm going to grab an M4 screw. Yep. So all the points around the perimeter that we're going to be installing stuff in right now is an M4. So once again, I'm going to load up M4x10s for anything that's up on the edge, and then the pieces that are going to be through the plastic, I'll do the, or I'm sorry, M4 by 8s. And then, no, M4 by 10s. That's right. We'll be doing M4 by 10. And then we'll do that is close. Like, there's a part of me. So on the annex, when we did the metal panels on the annex, there was a thin strip that we put between the panel and the extrusion to prevent marring and rattling, right? So this is just kind of fully pressed up there. Once I lock it down, it might not make that noise, but it's to get rid of some of the rattling that can happen with metal to metal like that. So hopefully this locks down well. But these 10s, they're kind of, I mean, they're right at the bottom. I would much prefer using M4 by 8s right. I just don't think I have M4 by 8 button screw. Got M5s. Now there's a few M5 items in here, but it's not a huge amount. So we have some M5 by 12s, which of course would be way too long. All right, we'll figure it out. What I'm going to do real fast is I'm going to grab an M5 and see if M5 fits in there. It doesn't, so those are definitely M4s. So we're going to have to go M4 by 10. It's going to be tight. And I would really, really like to be using M4 by 8s on. And so what we're going to do is we're just going to go through the panel and get our whatchamacallits set up. Making sure that we get a bolt into every spot that we're going to need to put a bolt in. But yeah, these would be better off with M4 by 8s rather than M4 by 10. How's it going, Rodney? Long time no see, my friend. Just getting off, so you're good now? Awesome. Well, I'll say that depends. So if you were on the East Coast and you were just getting out of work and you normally work regular hours, that would be bad. I know I had somebody that was conversing with me on a help ticket when I logged off at like 5 so I could get ready for the stream. Of course, it's one of those things that it's always an emergency. East Coast? Okay, well, that sucks. Like 9 o'clock. But once again, it depends on what your normal typical schedule is. So, okay, so this one. Still need to remember that we need these 3 in the middle. Yeah. Well, that's why I said it depends on what your job is and what your normal hours are as to whether or not it sucks. But okay, so those done. We'll need the bottom center. So and then once again, the ones on the side here, I'm just going to go ahead and continue to use the M5 by 10s because they should work in this application just fine. Good. And we'll come back over here. M4 by 3, 6 or 8. 20 of them, depending on the number of screws you use to secure your panels. Optionally, you can use the included enclosure trim piece, which are meant to use M3 hardware. Okay. M4 T-nuts, about 20 of them. M4 by 20, need 8. 4 by 25, you'll need 4. 5 or M8, wood screws. Every once in a while, I wind up dealing with a hammerhead nut that's just got really crappy threading on it. Doesn't thread worth a darn. I guess what I just had was one. This side we're going to get on, get fastened. Once again, that's the 10 and how much it pushes through. We're going to be going through panel and whoops. Good. have enough room to still be able to use these hammerhead nuts effectively. Now the fun part is going to be getting all of our peanuts lined up either vertically or horizontally so that we can get things latched in. Oh, excuse me. Part of the issue I'm having here, I can't tell if the peanut's actually turning appropriately in the socket. And really think that I should be using M4x8s in most of this. Ooh, and I can't set it fully down on the front face because of the that's what I'm worried about is this has bottomed out. It is not flush. So that's the issue that I'm going to have. I need to get some M4x8s or M4x6 or M4x8s and swap all of these out with shorter screws. Hey Matt, how's it going? Either that or part of the issue is screw is bottoming out, which is not allowing the peanut itself to actually rotate around and touch. And then, yeah, these are, I feel them locking, but they would have to have like a bolt or something behind them. Just bottoming out in the channel. So I need to I can drill them all out for M5s. I got plenty of M5s, but I don't have M4s, and I don't want to sit here and like cut down a bunch of M4s. M4s, I don't think I've got any M4 button heads. I have some M4 countersunk. Let me double check. Yep, those are M4 countersunk, and they are all way too big. Uh-oh. Uh-oh. Might we have there? What might we have there? Question is can I back these out and leave these nuts dropped straight down where I can capture them in place? I'm going to have to take this panel completely back off. And 4x6. Well, we might have a winner here, folks. How's it going, Matt? So the yellow things, well, this one has the whatchamacallit, the outlet socket in it. So that'll be our mains input socket. And then the other side is just the same basic structure for consistency and symmetry. And I have these M4x6s because well, that's what you normally use to secure your 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 English second language tonight. It's what you use to secure things to your DIN rail mounts, to your power supplies. We'll normally use those as well. So well, I have M4x6s here. I must have bought a package of them at one point. But yeah, this side is going to have the power inlet, and then also your AC power is going to be down here at the bottom. So it's to protect you and keep you from putting your hands in places that it should not be. That one's, whoop, nope, it did. It did, it just took a second. And once again, this is the lime. That's the Polymaker ABS lime color. I'm glad that I went looking for these. I would have been happier with 8s than 6s, but they're working. Cannot complain. Okay. So move that off to the side. We need it again. Let's get this lifted up. Okay. Put these back in there for now. Our back panel is fully on. Very nice, very sturdy. The M4x10s work really well for the for these lower panels, and like I said, they're going to provide the cover for all of our 110 and stuff like that that comes down through here. The other thing that we're going to need is our feet, and we're going to work on the top side or bottom side of this. So we're going to mount all the hardware on the back panel, put the back panel on the frame. It is easiest to start tightening, starting in the middle of each side and work your way out towards the ends to prevent the panel from bulging. Very true. Now we need to work on the feet. So to add the feet are going to go through the bottom panel. So I'm going to lay this on its side because I've added these, so I can't mount, or I can't lay it on the back anymore. So we're going to set this over on its side. That, try and give it a bit of an angle here. Or just turn it completely around, because we're going to put our bottom panel. And yeah, like I said, this side is going to be the inlet for our power. And then we'll mount our power supplies here very, very shortly. We'll start mounting that. Now on our instructions, which the focus for a little here. We've got a lot going on in this little diagram. So basically what it is insert all the hardware in the printed feet, mount the rubber feet inside. When scaling the printed spacer, make sure to get the height your rubber feet sticks out about 1 to 2 millimeters of the printed feet. So this is what we need to take a look at, which means I need to find my other parts real fast. Found my grommets. Didn't know how many to print, so I printed a couple of each one. So hopefully I got enough. If not, I'll print more. This, by the way, is going to be the baffle for the, this is the optional baffle to reduce some of the noise that our CPAP machine is going to make. There. Oh, yeah. Those feet, which I did not need. Give me 1 second here, folks. Top panel. Seem to have misplaced some parts yet again. Why aren't you guys yelling at me about misplacing parts? By the way, folks, Vision Miner, nanopolymer adhesive. I now can very adamantly swear by this. This stuff works wonders. I've been using Bedweld. Was this layer near Bedweld? I was using this after recommendations by BC and Royal Nomi, and it was a lot cheaper than doing the Bedweld. But after using the the nanopolymer, and after doing the nanopolymer, I'm sold. I'm sold. All right, what did I do with those 4 spacers? So there's going to be 4 round hockey puck spacers. You can print to different thicknesses. You can either print them out of a hard material, or I printed them out of TPU. And they're just little disc pucks. Oh, there they are. You know, I'd find them eventually. So I did mine out of TPU. It's not very, they're not very soft and flexible, but they add a little bit. What's going to happen is you're going to put this in there, and then So I think we are going to use these feet because the option is to use these feet or to use a different style of feet altogether. But you're wanting this foot to sit up just a few millimeters. This is actually, I could probably make that that spacer a little thinner. This might be an M5 versus an M4. But this takes an M4 down through that hole and then into an M4 nut here. That's what I got to do is figure out the length of that M4. Probably the M4 by 25. Most likely the M4 by 25s. Ends for burs. Those. Here's. Now we're going to be back into it. As soon as I decided, no, I want to use the other feet. Right back. Needing M4 by 25. Not about to start singing the praises again, and we're right back into it. So these are M5. It looks like we need M4s. 25 most likely. M5 by 14. They're not going to. But the gist of it here is you're sandwiching the foot so that your foot, even though it's a small foot, it's very little that's actually sticking out based on the spacer that you print, so that you sit in there easier. Now, what I will probably do is I'm just going to stick the M4 nut in here, and I will have to source some M4 by 25s, and I will actually do the insertion after I get some parts sourced, because I'm pretty sure I don't have M4 by 25. I say that, and then a thought just came into my mind, and I might. Hey, Killer Dragon, how's it going? Killer Dragon, I owe you a letter parcel, don't I? Hey, Nova Ninja, how's it going? Hope you're doing well. I'm doing good. I'm doing good. We're making some progress. Um, we've got our tool head initially mounted, our tool head being the Goliath, initially mounted. There's going to be some things I'm going to change between the streams, and that's simply because I want to change the position of the wire and how the wire comes out of the machine. But that's easily doable. Like I said, it's just more of taking the hot end back off and clocking it around in the sorry, I'm getting sidetracked looking at screws. 16s. I'm just going to clock it around in the position until it sits right. Now, I have some standard and I don't know if these are going to be long enough, but I've got some standard M4 by 20 kind of button Phillips screws. So I need to see if one of these is going to be long enough to go through my spacer, my foot, and into screw. If so, hooray, we have solved a problem. If not, then poopy donks. And I'll have to go and pay inexorbitant fees at, oh no. So without a spacer, you can see that that rubber foot sits down in there and it becomes basically useless. With the spacer, the way I printed it, it's slightly too short. I would definitely need an M4 by 25 screw to get down there because fully seated, it's just coming up where the nut is. It's not, I'm not going to be able to get it in there far enough. So, but I'm also, I mean, I could make it a little bit shorter. So it's either reprint those spacers a little bit shorter. But I'd have to go like at least 3 or 4 millimeters. And I'm sticking out 5. So if I reduce the height of those little spacer pucks by 3 or even 4 millimeters, then my feet will barely, they'll be like 1 to 2 millimeters sticking out, which is what it's actually telling us to do. So that's actually plausible. I just need to reprint these spacers. There's nothing that says, like this is actually TPU, nothing says it has to be TPU. So I wonder, Give me 1 second. We may get those printed while we're sitting here. That is perfectly good. All right, we're going to start warming up Fey Dragon. And once again, for those of you that are kind of new here, I need to wash this down. This is some residue from the Nano polymer on here, but this is going to be the deck panel for the Rook 2020 rebuild that I've been putting on KB3D's table, so I figured I might as well put a KB3D logo on there. And the way the deck panel's set, you could do an SKR Mini E3 V3. And over here, you have the option of setting up mounts to do like a Raspberry Pi or even a Pico. So I may even be looking at doing like a Pico with a Pi Zero. And then possibly running a power supply over here or something. I'll have to figure it out. But for now, we're going to throw that to the side. We're going to take a swig of some coffee. I think we got a solution there. This stuff back up. That's kind of why I never get rid of screws and stuff like that, because you never know when you're going to need a specific size screw. And I've always seemed to have found one rather than needing to go and buy another batch of screws. I complain about it, and then I always tend to find them. So, hey, Pezliz, welcome on in. How are you doing tonight? Hope you are doing well. Let me do a quick let me not cat up, but let me slice up those little spacers real fast. I need to make them 3 millimeters shorter in the Z. Going to Fey Dragon. ABS. Standard bronze stuff should be fine. So scale, scale, uniform. We're going to drop it from. Then we were going to drop it 4 millimeters, right? That would give us about a millimeter sticking out. So these are currently 6 millimeter. We're going to drop it down to 2 millimeter. To make it even faster to print. Okay. Let's try that again. Go down to 2.00 or that. That way it counts. Now down to 13 minutes. Hold off I'm sitting at just yet. It is over there warming up. Thought it was. There we go. Everything's warming up now. So we'll get these going. What I'll do is I should be able, like I said, to put the screws or the nuts and stuff in place as we get this attached through the plate. They'll become captive nuts. And we'll be able to attach those once those are done printing. Because once again, these are going to mount on the printer like this. We've got an M5 that's going to go through the bottom and come up through the frame. So we've got, excuse me, M5 or M6 25 millimeter. M6 would be if you had a, I think they refer to those as the European frames. Or basically if you buy them off of AliExpress, or not AliExpress, but Amazon or AliExpress, rather than being a properly sized hole for an M5 tapped screw, you will get an M5 hole, which you'll then have to drill and tap for an M6. So tugboat, to answer your question, Fay Dragon. So Fay Dragon is the purple and pink. This is the one that I built from the parts that I got from Remurf in 2023. It's also the one that I put the carbon fiber tubes on, that I'm seriously thinking about taking the carbon fiber tubes back off of. I am getting a little bit of flex and twist, and I have marred one of the acrylic sides has gotten some marring on it. So yeah. All right, so we need our M5 bolts. These are going to be for the feet. Tell me, I just put those up and I didn't pull out all of the I just put up all of my M4 bolts and didn't get out all 4 of them after I tried the one to see if it would. Sweet. Like when I do dumb things. Okay, we're going to need an M5. So an M5, the M4 in the middle, and then the other 2. Those going to be M4s or look like 3s. Those will be the M4 by 20s on those sides. Doing some deductive reasoning here because there's 8 of them, and each one of those legs has 2. That'll be the M4 by 20. So funny enough, we're gonna cut our spacers down and use M5 by 20s for the feet, which gives us just a tiny bit of clearance, which is good. So M5 by 25 will be through the center and into the holes. M4 by 20s are going to go through the feet and through the bottom plate. My assumption is that the holes here in the bottom plate are going to be towards the back. But I'm going to check the CAD real fast to verify that. And I would be wrong. They're at the front. Do not know why they're at the front. Do not actually know why there's holes there at all, but we'll go with it. So the holes are at the front of the machine. So we're going to do another AMS or ASMR peel there. Only on one side. I'm going to these holes are actually nicely deburred. So edges too, so we're good there. Once again, look how thick that is. That's pretty thick and chunky there. We're going to need to set up our feet. So we need a M4 nut that's going to be captive here. And a pretty nice tight fit for me. I know Steve had issues with his not pressing in very easily. We're going to need the M4 by 20s. Have to clean up my holes. So yeah, that Bay Dragon was built right after Murph 2023. That was one of the first builds I did right after that show. Sorry, Murph, as in Rocky Mountain, which is where I won the parts. So I worked with Tensor 3D to get a lot of what I needed. Got a few other things from KB 3D as well. And then we embarked on that build. And there should be VODs up on my YouTube channel that documents that build. So until you make partner with Twitch, you really can't keep content on Twitch that long at all. So that's why I always port all of my videos over to YouTube, because they stay there longer, they stand the test of time. So if you're ever looking for any of my videos, that's where you're going to find them. And I do have a couple of comments on my ERCFA videos. specifically around things like, hey, I'm following along on your build. I've caught up. I'm kind of stuck now. When are you going to tune it? So that, I can get mine tuned as well. So we're probably going to need to revisit that soon and start tuning the ERCFA. Been kind of dragging my feet because quite honestly, the critical piece that I need to get done is getting the black box build completed. That's got to be done for Murph because I've already committed to that. So there's our M4x20 that goes through the foot. We're going to go through our plate. We're going to need our M4 whatchamacallits, hammerheads. We need to grab those back out. Go ahead and I was going to go ahead and send that print over, but I'm not sure if we're up to the temp yet. Here we are. So I'm going to say go ahead and print, upload and print. Once again, use an Orca slicer. It goes right over to that printer and gets started going. So through the panel, hammerhead on it. Thread or two. Get the other one. Lined up through the panel. Hammerhead on that. We'll need to go around and do this to all four corners. That way we'll have a foot prep to go in on all four corners. And as soon as the print's done, things cool down, we'll be able to build our feet out and get those on there. Then we'll have our feet completely done. And of course, I'm going through and doing this and forgetting to do the middle ones at this particular point in time. So I got to go back and grab my M4 by. I'm going to grab and use my M4 by 6s because the M4 by 10s are still going to be too long. This plate is no thicker than the other one. So We've got the feet ready to go. We'll need to go ahead and get our 4 screws around the middle of the perimeter prepped and ready to go. This would really be better, a little bit better with them 4x8s, but them 4x6s will work for the time being. Hey Bexy, how's it going? Sneaking in. Good night to you, Miss Beans. You have a good little sleep tonight? I have one more of these and then we'll be ready to prepped and ready. Okay, now here's the issue I'm going to have. These feet kind of stick out from the edge some. So what I'm going to need to do is rotate this around so that the bottom is sitting off the front edge of the bench so that I can get things lined up. And installed. So the holes are towards the front. Come on, be nice to me. Ah. 80% of the way there. Okay, so all of these panels, this bottom panel is screwed and tightened. Everything feels like the nuts did twist and secure. That's good. Now, when our printed parts are done, we'll be able to add those and do the feet at the bottom. We still need to add in our 4 M5 screws. These are going to go through the corner and into the actual extrusion, into the corner extrusion. So this is going to be tied to directly into the corners and into the extrusions on the front and sides and back. This is going to be pretty darn rigid at this point with all of these. Winning games as well. Uh-oh, you guys doing marble races? Should be doing community marble races by now. So those are in. We should have, we're going to do a couple other things and then we'll get these feet added on. And the couple of things that we need to do, because I keep catching these and flipping them, and I'm going to break these acrylic panels if I'm not careful. So we've got spots for M3 screws and M3 screws and hammer nuts. So we're going to do that. Pretty sure those look like M3s and not M4s. M3 by 8s because once again 10s are going to be way too long, especially for the acrylic. 8s might. No, we're good with the 8s. 8s will work. 6s may actually work as well. 6s might actually be better. 8 through 10. Three by 6s. I think we just need 4 of them. Two at the top, 2 at the bottom. Ah, da, da, da. The bottom ones will be pretty easy because once again, flexes really darn well. Top might be a little bit more difficult to do. Just, dear God, if you're doing what I'm doing right now, be careful. You don't want to bust your panel, because if you do, it's a bad day. And once again, when you're doing this, be very, very cautious. You do not I know what I'll do for the put it over on its side again. You do not want to really crank down on these, or you will crack your acrylic. So just, you're just tightening the acrylic so it doesn't go anywhere. Oops. Ugh. Okay, so that's there. That's going to be awful tight, but if I lay it on its side, I should be able to slide the T-nut in without an issue. I'm going to put this back on its side again. The feet are on there now, so should be fine to set it on said feet. What I'm actually going to do is put the T-nut in there. Hit the screw in. And just like that, boom, done. I'm curious because there's this clear foam tape in here. And not once has it told me to use this on anything. I really, really hope I'm not supposed to be lining these panels and using that as the gap between the panel and the part, which would in essence be sealing things in, because I have not seen that said anywhere in the instructions. So the good thing is it probably wouldn't be too traumatic at the moment, but further I get along, the further it's going to be, or the more pain it's going to be. Okay, so what else do we have now? Got the back panel on. We've got the bottom panel. Inserted the feet. We still need to do the center rubber feet right here in the middle once our part's finished printing, which shouldn't be that much longer. Fume extractor. Well, okay. Fume extractor is an optional piece of hardware, but highly recommended. This device gets rid of VOCs, volatile organic compounds, and nasty smells that come from printing ABS filament. Definitely, definitely worth it. I'm normally running a Nevermore or something like that, so definitely going to be worth it to install that. So that's going to go right up here at the top of the printer. There is a grommet space here, so we do have a grommet that'll go there. We're just going to have to cut the brim off that I put on here. Probably be easier said than done. Downside of printing with TPU is trying to like deburr things or get brims off is very, very much a pain in the butt. Basically, you got to try and get a break at a layer line. And if you can get the break at the layer line, then it will allow you to follow around the layer line and just peel it apart. Just getting it cut to the layer line first. He's probably could have printed without a brim, but it was complaining and wanted a brim, so you know, I gave it a brim. So here's a little printed piece. It does have a little tab kind of on each end. It will go right through there. It's going to be a little bit of a tight fit. We're going to shove it in there. That's why there's a why it's split. Make it easier to get that grommet in there. So kind of crisscross it, push it through. You got a lip on either side, so once you get it in there, it will fit down just nicely like that. And that's going to give you a spot to run your wires through. And then we'll have other ones for all of these other holes down here. So there's a big one for this piece. And we had so we had deburred all of those edges, but you still want to use a grommet if at all possible. It's just added protection to keep your wires from having the chance to abrade on the metal. do this one over on this side. See a little bit more about what. Trying to pull the brim off. I think I did like a 3mm brim on both the inside and the outside. Once again, these are fairly small prints. I wasn't sure. It said it wanted it to ensure good bed adhesion. Probably didn't need to, but it's always worth it to ensure that your print's going to come out well. All right, Rodney, have a good night. Hopefully tomorrow you're not at work as late. Once again, this one also is split. It's that way by design. You're just going to kind of get one side shoved into your hole. And then you'll take the other side and bend that lip up. Get it pushed in and then push the two lip sides down. You're getting a little bit of a ring on each side. So it's completely sandwiched in a U-channel around that metal to keep anything from getting damaged. We've got another smaller slit that's going to go right down here in the front. Our print has completed. So we're going to get a little bit of time to cool down and do its shrinkage because we are printing it in Polymaker black ABS. Spacer underneath the foot, so I didn't feel like it needed to be like 100% color match accurate to the rest of the parts. But tugboat, yeah, like we were talking about, as soon as you get all the parts in from me and from KB3D, he's got the list. He's putting it together now. I haven't heard back from him as to when it's going to get shipped, so I'll reach out to him and see if there's anything that he's waiting on. But once I get word that that is shipping, then we will try and start setting up like what we're going to do as far as stream together, not string together, however you want to do it. I am game either way. Feels like it's going to be a little bit tighter to get in. There we go. There's a pretty thin slot. Really, there's only going to be a motor wire that goes through there, and I may wind up having to take that out to get the head of the connector through, and basically, you know, put the grommet back in with the wire already going through it. But I wasn't sure how many of these I was going to need. It looks like I needed 2 of the ovals, 1 of the thinner oval, and then 1 of this kind of trapezoidal shape. So I got a couple of spares that I can keep for another time. The exhaust parts are in here. Also, I still need to print 1 more of these, but this is, if I can get that on there, this is the RCSC2 ducting. So it gets, I think, 60-20 blower fans down here. And this will go on each side and get mounted on the side panel and provide sheet curtain cooling across the bed from each side. So there's going to be 1 of these on each side of the printer. I still need to print the second one. As soon as I'm done, well, as we get closer to needing these, I'll probably print the next one over the weekend. Right now I'm printing my Rook 2020 parts to have them ready. What do we need? We've got our, that was it, all right there. 1 shot, all right there, good. RCSC parts back in there. Okay, so we've got our shroud pieces. Need a couple of fans as well, I'm sure. VzBot fume extractor is an optional piece. Recommend, blah, blah, blah. Various screws. We'd like to look at what we're going to put together and then come back up and grab the screws as we need it, because oh, look at that. Looks like the Vanguard and the spacer and looks like, because that doesn't make any sense there, it looks like these pieces go on the inside to protect our fans. Makes sense. We clean up these holes real fast, because apparently there's no easy way. So this side has a depressed ring for this other piece to fit in. This side has countersinks for all those screw holes. So you're either you're stuck either using whatchamacallit, supports, or you're going to have ugly prints on one side or the other. At least this side, it's going to be in the back of the printer, a little bit harder to see, and also covered by the screw holes. So I'm going to open up these holes without opening up holes in myself. Once again, I'm doing this with a reamer, not a drill, to try and ensure minimal damage to this thin printed part, while still giving me a viable round hole to use to screw things together with. Okay, so we got that. Got this part. This part. Okay. I understand how things go together. We're going to have all of our pressed hardware in here. So once again, that hardware looks like M4s. M4 by 40s, 8 of those. Those are going to be for our throwing our fans in. M4 by 40s. M3 by, well, and some M4 nuts. So go ahead and get those press fit in here. Not necessarily press fit. These are a little bit looser fit. Not loose like they'll spin, but loose as in they're not going to be, if I flip this over, I'm going to have 8 nuts on the table, the ground, and everything else. So we're going to have to be gentle when we put these together. That's that part. And then we'll need some M3 hardware, which will be for joining the HEPA filter side plate in. So we've got our M4 hardware. We need our 60-60-25 fans. And these are, don't even give you a size. So nice. Airflow does travel in the expected direction, which means air's coming from the black side and coming out where the sticker is. So this needs to be facing forward. Okay. So what we're going to have is and had I realized that I would have done the Vez emblem in different color, I'm not sure if it's going to be worth taking everything back apart to do that, to make things pretty, but we'll see how I feel later. So screw there, do a screw down here. Get things initially lined up. Take one of my fans. Once again, the sticker side is going to be facing you all. Push that on. And try and get the rest of our screws pushed through. One fan on there and aligned. Same thing for the other fan. Or at least all of the screws are lining up. That's nice. Now we have our larger piece, nice and flat, so it'll go up against the edge here. We've got this spot down here. This is where we're going to have our wires coming out of. Going to go right around the fans. We need to make sure that our wires are properly routed through that gap. Just like that. And then this piece is going to go on like this. Is where I got to be careful that we don't lose our nuts. Like, there goes two. Okay, let me grab those nuts real fast. So the issue I had was it's offset slightly. And I do mean slightly to one side. So that's what I was doing is I needed to pull it off, flip it 180 degrees, and put it back in place. And one of those M4 nuts will be found later. It will be found later, and I will, hold on. You come this way. Nope, it hit the carpet and God only knows where it went. We should probably make a game out of me dropping things on the carpet. What do you guys think about that? Can we make a game about me dropping things? So Tugboat, I have printed all the parts for the Rook, both yours and mine. Well, let me rephrase that. Yours, and then mine is getting there. I've got 1 or 2 more pieces to go, or prints to go on mine. Are we not lining up? On number 2, just put this in the same order. The same direction, so I still need to turn it around because it's an ever so slight, it feels like, alignment issue, or not issue, but difference. Top to bottom, and I just dropped another nut. Lines up a lot better. Dropped another nut, and it went the same direction as the first one. We go ahead and get these started. It was oddly weird in the sense that it feels like this lines up like it's not lining up 100% perfect. Oh, I guess that could just be also that, yeah, we can make it closer. Screw it in. I'm like, why is that not tightening up? Because there's no nut there. So I'll show you what I'm seeing here. And I don't know, because all of these parts were printed at the same time. And I think I just answered my own question. Which is this big shroud piece can, well, it floats a little bit, right? So you almost need to massage things around to get it to properly align top, bottom, left, right. within reason, of course, because you're sandwiching the fans between all the pieces. There were everything there but this one, and this is the one that I now dropped through twice. See if I can find this one, because if not, I'm running out of M4 screws, or M4 nuts. I think I found at least one of them. The tugboat. Do you want me to spoil your surprise or not? Think you know? Yeah, I kind of did give you some clues already, huh? So the issue with my Rook is, yeah, the one of the belts is kind of gnawing on itself. It's getting chewed up. So I need to replace the belt. And in the process of replacing the belt, I might as well just rebuild it. But so once again, there's the bottom plate. I couldn't get the letters to match your font because I don't have the right font. And I got the same thing with KB3D. The inner part of the logo seems like it's darker. And I think it's because there's a couple layers of the blue here, and then there's a full black ring behind it as infill. So I think that's why the blue here is a little bit different than the blue out here. But I did my best to try and recreate your logo there. So I hope you like it. I hope you like it. And like I said, I've got your, I've got the hot end and the extruder for you. And then I was going to get I wanted to use a standard power supply versus a power brick. And there's just no way that it's working with the Meanwell LRS-350. I've got to see if we can drop down to the 150, which will be a little bit smaller. If so, we might be able to get that in there. If not, then we are going to have to go to an external power brick. I don't think it's as ideal because I don't like using the external power bricks if I don't have to, but we might have to. What I would just say though is when we get the external power bricks, just make sure and buy a spare. Ooh, if I can see. I got some new fans that came in, I didn't realize Mrs. Dragon dropped these off. These are 4-wire fans. These are 3826s, I think. Thirty-six 28s. 36 millimeters, like cubed fans with 28 millimeter thickness. And that's for the Calamity tool head. Uh-oh. Where did we get stuck on? Did we break filament in the... I had an issue where it snapped. For whatever reason, the nanotube gray tends to snap more. But it could be the way that I rewound it, because I'm still learning to rewind or respool stuff. So I'm going to bring you guys in here so you can see. See how there's like a visible gap there? And then up here, there's also a visible ledge. That's what I was trying to get rid of. I'm also seeing some gaps around the edge. It's probably some warping in that part. Which, once again, I'm wondering if there's supposed to be some foam tape, because I'm not seeing anywhere in the instructions here where it talks about using that clear tape free. Well, in my case, the issue I had with them was the cheap 24-volt ones that I was using for my other Rook. It's got a fuse inside it, but instead of being a replaceable fuse, it's still replaceable, but it's soldered to the dang board. It's the standard glass fuse. They just hard soldered it to the board. They had to like desolder both sides of the fuse and solder a new one in. It made no sense. But so be it. We need M3 by 25s. We'll do the same type of thing from the outside. M3 25. Need 4 of them, so yep, looks like it's going to be the socket head cap screws. Need 4 of the M3 nuts. And so this is going to screw right on top of this. And the nice thing with this is replaceable. You can cut a charcoal filter and a HEPA filter for this. I need to see if some other filters that I have already bought. Oh, snap. I needed to put these on before I screwed that down. Ain't that a... Well, that was fun. Guess we'll get another opportunity to see how many of my M4 nuts I drop. The build plate size is the same as a Voron V0. It uses a Voron V0 bed, 120 by 120. And there's technically 2 ways you can go about it for the bed. There are 110 volt heaters, so main heaters or main volt heaters for those beds. But that would require you to use a solid state relay, and then you can't use your brick, right? You'd have to use an actual standard uh, LED power supply. So that's what I would prefer to use anyhow. So we'll see what we can do. So the Micron had a, I think it was a Meanwell LRS power supply. So normally it's either a Meanwell or a Morn Sun has been the other one that people have been using a lot lately. And I keep looking for the Morn Sun, and unfortunately, I can't find somebody that actually sells the Morn Sun. You can get them from LDO with, buying an LDO kit, but ooh, wait a minute. Wait a minute. So I need to talk to Chris, because if he gets the Polymide heater bed for the LDO, seriously? So LDO had an upgraded heater bed, and it was a Polymide heater bed. And that bed requires we'll say a more robust power supply than a standard V0. And because of it, it comes with the Morn Sun when you buy the bed. So if we do that and use that upgraded bed heater, then we would get the Morn Sun power supplies that would work for our builds. Pretty sure they're smaller power supply than the Meanwell as far as physical dimensions, and it's the one that sits underneath my existing Rook 2020 today. Hit the edge of the shelf right there with one of the vanes. That hurts. 2, 4, 6, 7, 8's right there. Hey, Heidi. All right. That. Because you're undoing the wrong screw, Luke. Have I had a Micron before? Yeah. Remember at Rocky Mountain, I had a Micron and a salad fork, and I traded both at the show for hardware items. So yeah, I've had a Micron before. I really liked it. It was the Micron Plus, which was the 180 version. Guess I should put it that way. I've had a Micron Plus. There's everything pushed through. Now, let me actually put the M3 nuts in the back here. And of course, these are going to be semi-loose as well, because why would they not be? Of course, I just dropped one. Okay. Damn it. Excuse me. Sorry, guys. I've got M3 nuts on the floor. You know what? I've got a bunch of those. Just remind me, tally somebody, 2 M3s on the floor. And once again, these are semi-loose. They're not going to stay put. So they're not going to stay put, but now they're also not going to come out of their own free will. Some people would say, why did you just put tape there? Why don't you put super glue and super glue them in or something? Yeah, that's a valid point. That is a valid point. I'm not going to fight this. I am just going to go from the middle. Get down, then I'll go to the outside. Oh, okay. Holy crud. What do we got here? Bricker or tiny power supply. Yeah, so the polyimide heated beds that come with the the LDO polyimide heated beds for the V0, they come with a Warn Sun, I believe it's an LMF 224. There may be some other numbers in it, but it's basically a 200 watt 24 volt power supply. that's required because of the polyimide heater. It's a little more robust, requires a little more oomph. The standard one, you may have used the 150 24s, which should be smaller in fit. I just have to double check. I know my Fabrico Rook 2020 kit did use the Morn Sun power supply. So you want to print parts for IC3D? Can I mail them? We were managers last year, but we aren't this year, so we can mail them to people. So if you're saying you want to be an elf for the Toys for Tots campaign, there should be somebody in your area that would be collecting. And all you need to do is find out who that person is, like who's the area manager, and they can, you can print and then take your parts to them. Yeah, there should be an area person that can take your all stuff. Okay, so we've got our parts back in the way we did. I'm just going to put this back on here without putting any filter in. I'm going to have to, I need to see if some filters that I have already purchased fit. If they do, great. If they don't, then I'll wind up. Do I have? This is the top plate or a top plate for a bento box. So that fits in there, but it's way loose. So I could use a larger size HEPA and charcoal filter. So I'll have to figure out a source for those. I'll try and jump on the VzBot Discord and see if somebody's got a US source for the filters for this stuff. But I kind of like that it's calling for both a HEPA filter and the activated carbon filter. Now I use I've got a Holmes filtration system that sits this thing that you're seeing right here. This is the top of a Holmes HOLMES air filtration system. So that system, I actually have activated carbon filter like sheets. And so that would be something that would be perfect that I can then cut to size as needed. Sorry, I'm trying to fix my wire because it was falling down the sleeve of my shirt. So the activated carbon sheet, no big deal, but I need to try and figure out like the HEPA filter material itself and where I can get some of that. That I can either cut to size or is already a correct size. So I'll have to figure out what size that will be. that is put together. Electronics, wiring, and firmware. Now, interestingly enough, it shows installing the 11 o'clock. It shows installing the two power supplies flat. It's not. If we look at the CAD, if we look at the CAD over here, full display, it shows the power supplies are mounted to the back in a vertical orientation, and one side will be the 24 volt, of course. The other side will be 48 volt. So one of the first things you always do whenever you open up a power supply is immediately look and see what it's set for. They will normally always be set to 230. Why? Because plugging a 230 into a 110 outlet just means nothing happens. Plugging a 110 into a 230 outlet, on the other hand, sparkies happen, right? I had a boss that was helping us, and we finally had to politely ask her to leave after she blew up like 6 HP laser printers. And these were not the inexpensive ones. These were the like the full size, like waist height rolling behemoths with like 7 or 8 trays and stuff. Yeah, she blew 6 of those when I was over in Germany, because she kept plugging them into 230 outlets versus the identified 110 outlet. So what I'm going to do here is, once again, it talks about the electronics in the panel, and that's pretty much it. It just says like, hey, great, you're at this point. Install the LED strips, the main board, and the fan, or the not the fan, but the display. That's pretty much it. It doesn't actually give you any direction. So we're going to start looking at the CAD here. So I have it pretty much full screen. Let me see if I can shrink it down some. Go. Boom. Now I can see somewhat of what we're doing. So based on how this board lays in here, right? And hey, Royal Nomi, how are you doing? You've been sleeping most of the day away, and so you just woke up? Well, that's interesting. It's 11 o'clock. I'm still chugging along here, and I'm drinking more coffees. So I'll probably be the same way. Hey, Royal Nomi, since you just joined in, let me show you a couple of things. So I've been doing a little bit of industrious work here. So you know we're building a Rook 2020 with the tugboat guys. Well, here's the bottom panel, the deck panel. This will be the bottom of the printer. You'll have the bed come up and down. And then this is the underside where your electronics will connect to. But that's That's the closest I could get to their logo because I can't get the right font for it. And then, of course, I'm rebuilding mine, and mine always sits on the KB3D table. I need to wipe them down with some alcohol, I think, to get the remnants of the, this is Vision Miner Nano Polymer that I use to make sure that these things get well adhered. I'm using the Bamboo Labs engineering plate on the Bamboo X1C carbon. So clean it off a little bit. I probably need to do it a little bit more. You can still see some of it, but I've been using the Vision Miner nanopolymer adhesive for these, and the only thing that I feel is like I'm getting a lot of black bleed through because there's not enough. The KB3D is not deep enough, so I'm getting some of the, I'll say, the backlighting from the black, so it's not coming out as the deep blue or the deep orange, or not deep orange, but the orange that it should be. And then let me see if I can't get the tugboat off some as well. Because that is the same blue. You know, this blue is the same blue that's here, but I think it's just like, you know, 3 or 4 layers, and then the whole black circle is black underneath it. So I think that if I make these parts a little bit thicker, I might get the blue to be a closer blue. But yeah, I think these came out pretty well. I think they came out pretty well. I've got plenty of the blue and stuff. I may try and redo both of these, trying to make the logos just a little bit deeper into the part. But where were we? Okay, so with the way that the panel's laid out, so this is the main Superfly 8 board here. And then where you see these 4 fans, these are the 5160 drivers. So this is where we're going to need the 48 volt. So because of the way it's laid out, I want the 24 volt on the left and the 48 volt over here on the right. So our LRS-350 24 volt, we're going to mount on this side of the printer. The 48 volt will mount on this side. And then in our, we'll have some shorter DIN rail pieces down at the bottom. That's where we'll put our Wagos to break out our 24 and 48 volt power. So we'll keep those separated. That's what they're doing here. With the cable troughs, the way they are, is we want to keep 48 volts in this quadrant, 24 volts in this quadrant. Okay. So once again, 24 volt over on this side, 48 volt over on this side. This little gap right here is where the Z-axis comes through. And then these 2 grommets, the only thing I can think of is it's going to be the, it's going to be the, whatchamacallit, bed wires, or like the bed heater wire. Ooh, the RS, yeah, the bed will come through one, and the RS fans will come through as well. Now we're going to be going through a panel. It's going to be on the inside, so I'm going to plan on using the M4x10s. Once again, you're going into the side of a power supply, so you really don't want length, right? You want enough to hold it in place, but not enough that you could short circuit something. And out of the button heads that we have, we've got 10s and we've got we've got 10s and we've got 14s. And I believe our 10s, I can get it lined up with a hole. Yeah, I mean, we're sticking out here. Like a good 7 millimeters, which means these panels are definitely we're not going to use the 10. We're going to go back and grab our M4x6s, because that'll give me 3 millimeters of grab. Which will get me into this folded over steel chassis without going deep, because like if you look down in that side there, you don't want to be going in there and shorting out on a piece of electronics somewhere in here. And I don't want to open it up just to try and see like, okay, how much room do I have on this side for a screw to go in and not hit something else, right? So M4x6 will be perfectly long enough to get in there and provide an attachment point without causing an electrical shock. There's one. There's right up there by the motor. Need something that's shorter. Shorter and or, whoops. Or I can make my life easier and just move the belt and drop the bed down some to get it out of the way. That would be helpful. Feel like we're going to make sure that these are good and tight. And what that also does is it grounds this chassis to this plate, which could transfer into the actual frame based on all of our attachment points. So we've got one of them in, nice and strong. The other one, once again, we need to make sure that we flip that switch to 115 because this is now covered up. This one we still have access to. Now we're coming in through the two M4 screw holes on this side. And then, believe it or not, this becomes structure. And there's going to be another panel that comes down through here. And there's going to be M4 screws that go through the panel and cover up our electronics and with, twist knobs. So that's why we're setting up the electronics the way we are. As far as the walk over to the other side. As far as them coming out to the side, this is basically creating our electronics box. Similar to the electronics box that we have on the side of the Annex Engineering K3. That is in essence what we're doing here, is creating the electronics box for this side. Okay, so our power supplies are now installed. And folks, it is after 11 o'clock. So we will come back next stream and we will continue. All right, have a good one, Tugboat. Wi-Fi is given out. Okay. Yeah, so now we've got our two power supplies, one on each side. We've got our two power supplies, one on each side. These pieces become the lower skirt. We'll have the spot right here for our, let me get some of these screws out of the way. We're going to have the IEC socket on this side here. So this will be our power in. We're going to connect this power switch to both power supplies, right? Similar to what we do, we'll come out of here to Wagos, and then from the Wagos, we'll bring mains to both power supplies. And then we'll have another set of Wagos to transmit the 24 volt and the 48 volt power. Things starting to get heavy. We got our little front panel pieces, the little side panels on with M3s top and bottom, and then M4s at the little three-ways here. These screws right here at the front are going to be the tensioning screws. So we'll have knobs that go on here. I just need to print the right things because I didn't print the right ones. We've got our Goliath tool head here. The thing's not going on all the way, and I need to adjust where this is coming out, because the way it stands right now, my thermistor is going to come right out the front. That might be an issue, so I got to play around with locking the hot end again to get it to a different position. This is as far down as it goes, which will be blowing right at the nozzle. I do have nozzles on order. I've got 0.4 and 0.6 vanadium nozzles from, I think they're Slice Engineering, coming from KB3D. And I've got some 0.4 and 0.6 Undertaker nozzles coming from West 3D. But yeah, that's kind of where we're at. The tool head is coming together nicely. There's going to be a lot more to get done once we start on the electrical. There is nothing in the instructions about doing the CPAP or anything like that. Oh, thank God. I wanted to check because some of the instructions I saw said locate where you want to put your RCSC, the static air system that's going to blow in from the side here, and drill the panel holes. There's holes already here appropriate for mounting that, because that system gets mounted to the side panel, right? So that's good that the holes are already there on the side panels. We were talking about the rear cover for the electronics deck. Let me twist this around. Again. So here's our electronics deck, and here's the panel that's going to cover our electronics. Once again, we're going to get the nice Vez logo, and there will be, we'll call them thumb screws, that'll go in to the other side of our power supplies, and this will be the cover that keeps fingers out of the electronics. So pretty neat, pretty cool. We are making some good progress, and I think that's where we're going to leave it tonight. Let me see if there's anybody out there that we can still raid into. Oh, duh. Zombie's up. Let's go ahead, raid into Zombie. I believe he was going to be working on the Doron Velta build. He is not on camera at the moment, so he's going to pick something up. So I'm going to go ahead and get the raid started. Everybody, thank you for being here. Thank you so much for tuning in. We've made a lot of good progress on our tool, or on the build, and I'm really liking the way this build's going together. So thank you all for being here. We'll be back on Saturday. The VzBot will not be up here on the table. Saturday is going to be a black box build. So we will be working on black box then. Please come on with me as we go over to Zombie Hedgehog. And I will see you guys Saturday morning, 10 a.m. sharp, Eastern time, for the black box. We get back into working on black box. Thank you, everybody, and have a great night. Okay, Pez, see you soon. Bye, everybody.